Hello students, this video will start uh, explaining different normal forms that we can apply on relation schemas in order to enhance them and avoid the update anomalies that we have talked about in the videos at the start of chapter 14. So first of all, we need to define what is normalization of data. Okay, normalization is a process during which unsatisfactory relation schemas are decomposed by breaking up their attributes into smaller relation schemas. So, in normalization, we have relation schemas that are not well defined and that contain, for example, two entities at the same time. And while applying normalization on these relation schemas, we decompose or we break the attributes of this schema into two smaller relations. Let's take an example. Mm, for example, that we have a student and an advisor. In this relation schema here combined together, and the list of attributes for this relation schema are student number, student name, major, and the advisor number in addition to the advisor name. So we combine both students and advisor in the same relation schema and combine their columns at the same time. This has several problems as we negotiate and discuss at the beginning of chapter 14. For example, we may have insertion anomalies, update anomalies, and delete anomalies. So in order to solve these problems, we need to decompose sorry, we need to decompose this relation into two separate ones, like we do here. For example, the student advisor is decomposed into student alone and advisor alone, and putting the columns for student in one relation and the attributes for advisor in other relation. So for example, student will take student number, student name, major, and the advisor number for this student, and the advisor will take the advisor number and the advisor name. This is more better design than this one, because in this design we get rid of the update anomalies, because this design is so flexible. But the one problem for this design is that it pays the price of expensive joins. For example, if we have a query to find the student name, each student name with his advisor name, then if you want to apply this query on this design, then I need to make a join on these two tables, because these two data is found in different or separate tables. So I need a join, and here the join will be made on the advisor number, which will return each student name with the advisor of this student. So this pay the price of expensive joins. However, if we do want to apply the query on this design, then we can get directly the student name with his advisor in less time. So there are advantages and disadvantages for both the two design, but overall this design is better when comparing with this one, because it separates the logic of these two entities alone. Okay, so before discussing 1NF, 2NF, 3NF, and BCNF rules, we need to put some basic definitions. So we have a relation R with set of attributes A1 till AN. We need to know what is a super key, what do we mean by a key, a candidate key, and the prime attribute. Let's begin with the key and candidate key. A key is a super key with no redundant attributes. So a key is used to differentiate between rows in any table. So for example, in this design, student number is the primary key for this table student, because no two rows or no two students will have the same student number, so we can differentiate between these rows or tuples using the primary key or the key here as the student number. Also, like the advisor number and advisor entity or an advisor relation. So a key is a super key with no redundant attributes, which means the removal of any attribute from the key will no longer make it a super key. So it is the minimal key used to differentiate between any two rows. The same, this key is the same as the candidate key. However, in any table we may have two or three candidate key, and we choose one of them as a key or as the main key for this table. So a candidate key, if a relation has more than one key, each is called a candidate key. One of these keys is arbitrarily chosen as a primary key by the database designer. However, a super key is a key or a candidate key in addition to extra attribute. So for example, if the student number here is the key or the primary key, then student number with the student name, we can call it an super key, because a super key contains an extra attribute. If we remove this extra attribute, which is the student name, we will return back to the main key or a candidate key for this table. So a super key is a set of attributes S that is subset of R, which is the set of attributes for this table, and T1 of S, and the value of this column in row 1 or tuple 1 is different than the value of this column in tuple 2 or row 2 for all I belongs from 1 to n. For all columns, that means S may contain redundant attributes, like we say, as we have said, the student name is an extra or redundant attribute in addition to the student number. So we need also to define and differentiate between a prime attribute and non-prime attribute. A prime attribute is an attribute which is a member of any key, primary or candidate. Other attributes are called non-prime attributes. So in each table you have, if you know the primary key and candidate key, you can know the prime attribute, because prime attributes are the attributes that compose the that consist the primary key or candidate key. So for example, here the student number is a prime attribute because it is a part of the primary key. Let's take other example. Let's take this example here. If you have the SSN in addition to the student number and name, address, and salary. So in this relation, we have the SSN and the student number are candidate keys, and like we said here, SSN and the student number are candidate keys. So one of them can be chosen to be the primary key, and here the database designer choose the SSN as the primary key. The prime attributes are all attributes that are part of the primary key or any candidate key. So the prime attributes here are SSN and student number. However, a super key let's take the non-prime before. The non-prime attributes are all attributes that are not prime. So if the prime are SSN and student number, then the remaining will be non-prime, which are the name, address, and salary. A super key, as we have said, a super key is any candidate key or primary key in addition with an extra attribute. So we can tell that SSN and name is a super key because it contains extra attribute, which is the name. Because if we remove the name, then we get SSN, which is a primary key. Also, SSN and student number with name, address, and salary can be called a super key, because if you remove student name, address, salary, and student number, or SSN you can get a candidate key or a primary key. So in the next video we will discuss the first normal form rule, which is 1NF. So stay tuned.